All right, for our next unit, we're going to talk about solving equations. This first page in your notes is kind of a flow chart for you to check back on and help you determine what to do when you get stuck, when you're not quite sure what to do next. So the first thing you need to look at is if there are parentheses. If there are not parentheses, then you move on. But if there are parentheses, that means you need to distribute first. Then you need to look at, can you combine like terms? Well, like terms are exactly the same variables. For example, if you had 3x and 5x, they both have an x, so you can combine those on either side of the equation. So you combine everything on the left side of the equation, everything on the right side of the equation. If you can't combine like terms, then you move on. If you can, then you combine the terms. Then the next one is, are there variables on both sides of the equation? So if you had, let's say that you had 3x plus 4 equals 2x, they both have a variable. Remember, variables are the letters of the alphabet. So if they both have a variable on each side of the equation, then you move them to one side of the equation using inverse operations. If they don't, then you combine or simplify the variable side of the equation. Once you've combined or simplified the variable side of the equation, then you need to determine, is there a number or a constant not attached to the variable on the same side as the variable? For example, if you had 3x plus 4 equals 10, this 4 would be a constant. So if there is, then you move to the other side of the equation using inverse operations. If there's not, then you combine or simplify the number or the constant side of the equation. Is there a number attached to the variable? No. Then, you're done there. Is there a number attached to the variable? Then yes. If attached by multiplication, then you divide. If attached by division, then you'll multiply. If attached is a fraction, then multiply by its reciprocal. So all of these are inverse operations. You are doing the opposite of what it is currently doing. All right, so now moving on to the notes for two-step equations. When we want to solve equations, so solve equations, we always want to get x by itself on one side. So we do inverse operations. The inverse is the same thing as opposite. So inverse of addition is subtraction. Inverse of subtraction is addition. Inverse of multiplication is division. And inverse of division is multiplication. So we're going to do some examples. If I want to solve for x, so this x right here is what I want to be by itself in the very end. So the first thing we need to do is I always draw a line so I can distinct so that the left side is distinct from the right side, so that I know that I have two sides I need to balance out, kind of like a scale. So the -1 is by itself on its right, so on the right side, so I can't move the -1. You don't want it to where there's nothing left on one side. So I'm going to have to move this 4 because the 5 is attached to the x. So I'm going to subtract 4 from each side. And now I have -x over 5 equals -5. And we look at the inverse. So obviously we did the inverse of +4, so we subtracted 4 from each side. And now we need to do the inverse of divided by 5. So we need to multiply by 5. The problem is that this x also has a negative sign, so we're going to have to multiply by -5. By doing that, this becomes 1x on the left side. And on the right side, a negative times a negative is a positive. 5 times 5 is 25, so x equals 25. On example number 2, and obviously if you want to be attempting this on your own, you can press pause and then press play when you're ready to check your answers. So for number 2, we want to solve to where it's just that x by itself. So the first thing we need to do is subtract 4.7. So 6.2 minus 4.7 is 1.5. And now I have 0.25 times x. Again, we do the opposite or the inverse operation. 0.25 is being multiplied by x, so now we need to divide by 0.25. And 1.5 divided by 0.25 is 6. And finally, the last one, this should be the easiest one because there's no fractions or decimals. We need to add 4 to both sides. So now I have negative a equals 9. If you don't have a number in front of your variable, I always put a 1 there so that I remember that I have to divide by negative 1 since it was negative a. So a equals negative 9. Moving on already to 3.2, solving equations with like terms and distributing. So like terms, these are terms with the same variable and exponent. So, for example, 5x squared and negative 8x squared, they both have x squared, so that's an example. A non-example would be like 4x to the third and 2x to the second. That is not true. That can't work because they both don't have the same exponent. They have the same variable, but not the same exponent. So combine the following like terms. So we need to find everything that's the same. So I have a positive 3y and a negative 2y. If I combine those, I get 1y. Then I have a negative 2x and a positive 4x. If I combine those, I get a positive 2x. And then we have that 5 left over. It's a positive 5, so plus 5. So we combined everything that we could. Now we're going to work on distributing. I don't know if you have done a lot of distributing with the area model. So I'm going to show you first with an area model. So let's say that I have 5 right here, and I have W and 3 here. Notice how W and 3 combine to make that length of that box. Now we just need to find the area of each individual box. So 5 times W is 5W, and 5 times 3 is 15. So the total area of 5 times W plus 3 is 5W plus 15. So this would be the area model. Another way to do that would be to do the arrow model. So I have 1/3, so I draw my arrow to show that 1/3 is being multiplied by 3x. So that's saying what is 1/3 of 3? That is 1x. And then 1/3 times 6, so 1/3 of 6 is 2. So those are the two models. Go ahead and pause now and see if you can do 4 on your own. Try whichever model that you prefer. So for number 4, negative 4 times 2x is negative 8x, and negative 4 times negative 5 is positive 20. So those are your 3 answers to distributive property problems. So solve the following equations first by distributing. If I could spell distributing, then combine like terms. So first I'm going to draw my line to show my two sides of my equation. So we have to distribute first. So 7 times a is 7a. 7 times negative 2 is negative 14. Plus 5 plus 2a equals negative 18. Now we need to combine like terms. So 7a and positive 2a becomes 9a, and negative 14 and positive 5 becomes negative 9, and this all equals negative 18. So just like in the flow chart, I don't have a variable on both sides, so now I just need to move the constant to the side with the other constant. So we're going to do the inverse operation, and now 9a equals negative 9. Now again, we do the inverse operation to solve for a. So since it's being multiplied, we now divide, and a equals negative 1. Again, if you would like to pause and try it on your own, you can. So number 6, we're going to do distributive property first. This 4x needs to be brought straight down because it's not being distributed. Now negative 3 times 2x is negative 6x, and negative 3 times 8 is negative 24, and that all equals negative 12. Combine like terms. So 4x minus 6x is negative 2x, minus 24 equals negative 12. We need to solve by moving the constant over to the other constant. So we're going to add 24 to both sides by doing an inverse operation. Now negative 2x equals 12. We need to do one more inverse operation, so divide by negative 2, and x equals negative 6. This is going to be our last example. The only difference between number 7 and what we've done before is A, we don't have distributive property, and B, they have the variable on the right-hand side. That doesn't change anything. It's just a different way of answering or showing your answer at the end. So we're still going to start by combining like terms. I can combine the 9 and the positive 5 to get 14 minus 2x, and that's all equal to 34. We still are going to move that constant over, so we're going to subtract 14 from both sides, and now I have 20 equals negative 2x. Remember, anytime you have a subtraction sign, it's the same thing as a negative. So we're going to divide both sides by negative 2, and negative 10 equals x. If you choose to write that as x equals negative 10, that is correct also. It doesn't matter how you choose to write it. That is all for your notes. Good luck.